Okay, this is geometry recording for Thursday, October 4th, and we are in second hour right now. And I recorded this first hour. I might put both of these on my Yola site or just one. And I'm just going to show each slide for this lesson. You should have 3 handouts for this lesson, and this is 1/8 three-dimensional figures. The essential question: can you identify, name, find surface area, and find the volume of 3-dimensional figures. And you should have written your level of understanding there. Yesterday, I gave you the opportunity to, if you wanted to put some things in, to identify some solids on the table over there. And so you could actually physically see the 3-dimensional shapes. Here's the ones that we named. You'll be naming these for me today. So just a reminder: sphere, hexagonal prism, triangular prism, cone, square pyramid. We saw a cylinder, a cube, a square pyramid, a triangular pyramid, and a hemisphere, which is half of a sphere. And then we're going to look at this where we're identifying 3-dimensional figures. There are no key terms, but there really are a lot of key terms, but I'm giving them all to you on a handout. So lots of really definitions as we look at this. I'll read this and highlight kind of the important parts. A solid with all flat surfaces that enclose a single region of space is called a polyhedron. So the definition of a polyhedron is a solid with all flat surfaces that enclose a single region of space. And so that is the definition of a polyhedron. Each flat surface is called a face. So that's a flat surface is a face. And the line segments that where faces intersect are called edges. So edges are line segments. You'll be asked to name a lot of line segments today. And then a vertex is a point, so a point where 3 or more edges intersect is called the vertex. And so I think you'll be able to identify all of those pretty easily. One thing I will tell you is the faces are all of the surfaces on that shape, so all of them, and then the bases are usually 1 or 2 of those. Is there anyone else who needs any handouts here? And they should have been maybe in your group folder if you weren't right in the room. Anybody else need anything else? You should have 3 handouts for this section. And so we'll just kind of make sure. So let me just restate that. So all of these surfaces are faces, and then 1 or 2 of them are additionally the bases as we go. And so for this one, the top and bottom are faces and bases, and then the ones that go around the side here are just faces as we go. In Minnesota, we don't do oblique, and this is an oblique prism. And if I set it on that desk, it just looks like it's tipped a little bit as you kind of look at it, and it's not perpendicular to the base. In anything we do will be perpendicular to the base. So if I accidentally assign something in a homework that is not perpendicular, then just be aware that, you know, that's probably a mistake that I made as I went through. And so faces of a polyhedron can be parallelograms and not rectangles. Ours will all be rectangles, bless you, and as we go through that. So here's our types of solids that we're looking at. And the first ones are polyhedrons. And there are 2 basic kinds of polyhedrons, a prism and a pyramid. So a prism has 2 parallel congruent faces called bases. So 2 parallel congruent bases connected by parallelogram faces. And ours are really going to be rectangles, just letting you know that. So this one, 1, 2, 3, 4, 5. This one looks like it's a pentagon on top and bottom, so that would be a pentagonal prism. A pyramid has one A base, so it only has one base, and its faces are triangular faces that meet at a common vertex. So the vertex is that point at the top, and the base is the shape on the bottom. Just a reminder for anything that has that pointed part there. So if we have a pyramid, oops. If we have a pyramid, it goes to a point at the vertex, but the base could be a triangle, it could be a square or a rectangle or anything, and these are still polyhedrons for those. Then there are a few things that are not polyhedrons, and our things that are not polyhedrons we're also very familiar with. It's a cylinder, a cone, and a sphere. And so a cylinder, it's still a solid. It has circular bases connected by a curved surface. And then a cone has a circular base, and it also has a curved surface and a single vertex. And then a sphere is the set of all points in space that are equally distant from a given point. So a circle is on a flat surface, everything that's equidistant from a given point. But a sphere is the set of points in space that are the same distance from the given point. And a sphere has no faces, edges, or vertices. So we can't really name any of those things. We can just name the sphere. Sometimes by its center we will name it. And then our polyhedrons have names based on their shapes and of their bases. And I do want to say this for sure. So this is a triangular prism, no matter how I hold it, right? So the bases have to be these triangles that are on the top and bottom. So in this little picture, and today I'll just tell you because I'm recording this lesson, when I draw in yellow, it'll be something that I'll be erasing. So, oh, well, that isn't yellow, but I meant for it to be yellow. So the triangles here are in the front and the back, but that is still a triangular prism as you look at it, because it's the bases are triangles. Because remember, if it's a prism, these have to be rectangles. So these can't be, the faces that connect the bases have to be rectangles. And so if I lay it like this, the bases are still the triangles as I go. And then same thing with this one. No matter how I set it someplace, the bases have to be the two hexagons. The faces that go up and down have to be rectangles. And so even if I can't call this a rectangular or quadrilateral kind of prism as I go. So here are the names. You should be familiar with those. If you looked at them yesterday, it should have reminded you. A triangular prism, a rectangular prism, that is where the base does not have to be square necessarily. Pentagonal prism, a triangular pyramid has a triangle on the bottom and then goes to a point. Rectangular pyramid could also be a square pyramid if we know it's a square. Pentagonal pyramid, pentagon on the bottom. Now, a regular polyhedron, that's the next thing that we have a definition, has all of its faces are regular congruent polygons. And so that's going to be down here below this. So all faces regular congruent polygons, and all edges are congruent. So all faces regular congruent polygons, and all edges are congruent. There are 5 of these polyhedrons that exist, and they are called the Platonic solids. And the reason they're called the platonic solids, as you can see the word Plato in there, is because Plato used them extensively. You have to know the first two. I'm telling you that. You only have to know the first two, but you are expected to know the first two. And I'll go over all of them with you. So you are expected to know a tetrahedron. And that may or may not be familiar to you. It's 4 equilateral triangle faces. So if you look at, I have a couple tetrahedron, or excuse me, I have a couple of triangular pyramids here. I want you to notice neither of these are tetrahedrons. You should be able to tell this one is not a tetrahedron because look at the bottom. Do you agree that looks like an equilateral triangle, correct? And I'm holding up this kind of yellow thing for those of you who aren't here. And so if it were a tetrahedron, all 4 of these triangles, 1, 2, 3 on the top and this 4th one on the bottom, they would all be exactly like that. And they're not. These 3 are not the same as this one, and they would all be equilateral. It would be 4 equilateral triangles. So this is not a tetrahedron. When I hold up this one, sometimes it looks like it's close to a tetrahedron. This bottom that I can take off, this bottom is equilateral, okay? Does that make sense? But you can see, and I'll kind of just hold it up so that you can see, the ones on the 3 that are go around here don't match that perfectly. Do you see that? So they're not the exact same. And so that is not going to be a tetrahedron either, even though it's kind of close looking to a tetrahedron. And so a tetrahedron would have all of those triangles equilateral and the same. And then the other one is a cube. And we're very familiar with a cube. And hexahedron is what it's called. Remember, a hexagon has 6 sides. What does a hexahedron have? 6 squares. Does that make sense? So top and bottom, 1, 2, 3, 4. So it has 6 square faces. So those are the 2 you need to know. And a cube you're already familiar with. Tetrahedron, if you weren't, make sure you become familiar with that. And then I'll tell you about these other ones, but you don't have to know those as you go. An octahedron has 8 equilateral triangular faces. So octa is 8. It has 8 equilateral triangles. A dodecahedron has 12 regular pentagonal faces, and an icosahedron has 20 equilateral triangular faces. So those are the platonic solids. You have to know the first 2 as we go through that. Then the next handout has lots of formulas. So find that one and make sure that you're ready. Yeah, okay. Do you have this one? Okay. Yes, you should. Okay, and so this is about surface area and volume. So the first thing that we're going to just kind of remind ourselves of is units before we kind of go over this. So surface area is a 2-dimensional measurement of a solid, the surface of a solid figure. So surface area, 2-dimensional measurement of surface. It's one of those surfaces. The surface area is the sum of all the areas of each face. And if you forget the formulas that are on here, you can actually find the area of all these. Ooh, just dropped that one. You can actually find the areas of all these triangles. You can find all those triangular areas and add them together and get the answer. But we do have some methods that make kind of finding, some formulas that make finding those a little bit easier. And then volume is the measure, of the amount of space enclosed by that solid figure. Then just a reminder from previous work and the work that we're going to do now. If you're finding a perimeter, that's just in regular units. If you're finding an area, that's in square units. Give me a head nod. Yes, we're all aware of that. And then volume, and it's easiest to think of finding the volume of maybe this cube. I take the length times the width, or the side times the side, to get the area of the bottom. And then when I multiply by this other side to get kind of that filled in volume, then I'm taking a dimension times a dimension times a dimension, so it's in cubic units. Someplace on here where you can find a little spot, or if you have it glued in and you want to write this nearby, that's fine. I'll try to write it on here. Just a reminder that perimeter is in units, area is in units squared, and volume is in units to the third, or units cubed. And when you do take quizzes now, I expect you to label things correctly. So you want to kind of have a little note about that. Generally, when I'm writing on the slide in yellow, it's because we're going through it and I'm recording this, and a lot of times the yellow things I'll just write on here and then erase them as we go. So surface areas and volume. First thing I'm going to do is just go over these terms at the bottom, and I'll start by just writing in yellow, and then I'll get rid of that. So just to kind of know these words as you go. Yep. A question? Okay. Then just a reminder, S is going to stand for total surface area. You don't have to write this because I'm doing it in yellow, so that means I'm going to get rid of it. Perimeter is the perimeter of the base. So if this were what I was looking at, the perimeter of the triangle on the bottom there, or if I was looking at this perimeter of the base, which is the bottom there, and if I was looking at this one, the perimeter of the base would be right here of that bottom. Capital B is the area of the base, and keep in mind, if I have these shapes that I have right here, the bases have different shapes. So this base is a hexagon. This base is a rectangle. This base is a triangle, and this base is a square. So when it says the area of the base, that means whatever shape that is, and we learned how to find areas of polygons in a couple sections ago, and so you can refer to those. Volume is something you're familiar with already, and then there's a couple of different heights. You either are talking about, in these formulas, the height of the whole solid, or something called the slant height. So if we're looking at this, the height would be this edge right here. If we're looking at something like this, the height goes up through the middle, and I did have that like this. So the height of this is from the tip of the vertex there down to the middle of the bottom. So that's the height of this. If I go along this edge, it's kind of tipped. That's called the slant height. And slant height is called L. Radius is R. This triangle, if I have to find the area of this base right here, I know that the formula for the area of a triangle is 1/2 base times height, correct? 1/2 base times height. Okay, the base and height on this triangle are not listed at all on here. when it says find the area of the base and height of that triangle, that's not the same as the height of the whole shape as I go. So I have to kind of look at that little picture and figure out what that base and that height are kind of as I go through that. So just be super aware of what they're telling you for these dimensions. And then here's kind of our easy to look at guide. And I will draw some things on the side here. So I want you to think about, I'm holding, I'm going to call it a square prism. Correct? And so these are the faces that go up and down are all rectangles, and the bases are squares. If I draw that and I say I'm going to peel these all apart, do you agree if I laid them side by side, I would get 4 rectangles? And then these squares would be, you know, something like that. Do you agree if I could unfold this shape, I would have those? And so what I'd like you to notice for this, and I'm going to write in yellow so I can get rid of it, but this surface area, do you agree that I could find area, and add them together, correct? That works. But this formula says you can do that a little quicker by finding the perimeter of the base, which would be all adding these 4. The perimeter of the base is along there, do you agree? Times the height. So you're finding all 4 of those areas at once. Does that make sense? So we can find all 4 of those areas. So that's why we do this perimeter around the top or bottom of the box. It doesn't matter which place you find that, but that perimeter times the height, which is the height of the whole shape right there. And then you need the top and bottom areas. So that capital B is the area of the base, and then you double it to kind of get that whole thing as you go. And so I'll just kind of leave that there a minute to remind you. And then volume is area of the base times height. So notice, the formula for volume is the same for all of these. Do you agree? Right here. It's the same area or volume. But for this one, you have to find the area of the triangle, and then times by the height. This one, you have to find the area of the square and then times it by the height. And this one would be the most challenging. You'd have to find the area of that hexagon and then times the height, okay? So that capital B can mean a lot of different shapes. This next one, do you agree that if you were looking at this, you could find the area of that triangle, the one in the back and the one on the side, and then this rectangle or square, whatever it happens to be. So each of these triangles, if we kind of think about going around, there's the perimeter, and the slant height is the height of each of those standing up triangles, and the area of a triangle is 1/2 base times height, and so that's how we're getting kind of that area of this triangle. We're finding all of those triangles at once as we look at that. And then capital B, there's only one base. For a cylinder, think about a can, a soup can maybe, and that label of the soup can, if I took it off, we know that a soup can label is just a rectangle, correct? It's the shape of a rectangle. But this distance around here, is really that distance around that circle. And so that is the circumference. And the circumference is 2 pi r. And so that's 2 pi r is really this dimension along here. And then the height is up and down like that, so 2 pi r times h. The area of a circle is pi r squared, but there are 2 of them, and so that's why we multiply by 2. So if you forget these formulas, they are kind of there in your work as you want to look at them and go through things for yourself. Then for this one, back here, I want you to notice that the volume of a prism is area of the base times height, and a pyramid is 1/3 of that. Same thing for a cylinder. The volume of a cylinder is pi r squared h. Pi r squared is the area of that circle times the height. This is 1/3. So how many of these volumes should fit in that? 3. Does that make sense? Okay, this is 1/3 of that. So if I use 3 of these, it should fill that perfectly. Do you agree? Okay, because I happen to have this little demonstration for you. So this is a cone. This is a cylinder. Stop. They have the same circular bases, okay? So the circles are the same, and they have the same height. It's a little wet, but they have the same height. So if I fill this one with water 3 times and pour it in there, should it make that one full? Yes. So that's what I'm going to do. And by the way, I am using water. I'm not very careful, and I do spill, but it is water out of this water bottle that I opened first hour. And you know, it all works out because I'm doing this kind of left and right-handed. I'm maybe going to have to. So there's one. And does that visually look like it might be about 1/3 of the way full there? And so there's one of those cones in the cylinder. And then here's another one. Oh, I'm doing much better than first hour. Well, I've been able to practice once today already. And there's 2, and notice, like, you know, now it looks like it might be about 2/3 full. And then here's my third one as I do this, and we'll see if it, you know, if it doesn't spill. So, and I don't know if you can tell, but that is just like right up to the top there. And so three volumes of that. Oh, now I'm spilling. Oh, now I'm spilling even more. But 3 volumes of the cone made 1 volume of the cylinder. So when we know the volume formula for cylinder, we just divide it by 3 to get the volume for the cone. And I could do, you know, something with this one, but I'm not going to. And so surface area of a sphere is 4 pi r squared, and volume is 4/3 pi r cubed as we go. Now, first hour people told me on this handout I did not give enough room. So I'm going to tell you on this handout I did not give enough room for this problem as we go. And so just be ready for that. So to compensate, this is what we did, and they didn't know this ahead of time, but you will. So for number 1A, we're going to write every single thing. For B, we're going to say them, but we're not going to write all the parts, okay? So if you have to creep into B a little bit, and then C, we won't write very much at all. There's not as much to write as we go. So as you know, I'm going to just be pointing to you or calling on you by tapping your desk or just kind of indicating that you're going to tell us something. And then I will either repeat your answer or I'll rephrase it as we go. So 1A, determine whether the solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. And so if it's a polyhedron, we can name all those. If it's not a polyhedron, we'll still name whatever of those that we can name, okay? So the first thing is to name the solid. And so what do you think that solid is called? A prism. And what kind of prism is it? A rectangular prism. And so I'm just going to write yes because it is a polyhedron and it's a rectangular prism. And we just said you're going to need a lot of space for this one. And the first thing we're going to do is we're going to name the bases. And when we name the bases on this one, the bases are going to be rectangles. So you're going to say the word rectangle and then just the 4 letters. And do you want to make the bases just the top and the bottom? Is that okay with you? Okay, so we're going to write the word bases. And go ahead and tell me the word that I just said and the letters that go with it. So you're telling me this one and that one in whatever order you want. Go ahead. What's the word you're going to use? they're rectangles, and you're just naming them. Say it one more time. GEFH, and what's the other one going to be? CDBA. CD. So those are the two bases for that, and I'll erase those now that we've kind of seen them. When we, I'll maybe leave them there a few more minutes. Then the next thing we're going to list is all of the faces. And since this is a rectangular prism, it has 6 faces. And the first 2 faces we can name are the bases. So I'm just going to rewrite those. So we have rectangles, and they're all rectangles here. Rectangles, GEFH, GEFH, comma, CDBA, comma, and then you're going to name all the rest of them, and we're going to go one at a time. You're going to tell me the letters of one of these, either the front, back, left or right, and tell it to me, and then I'll repeat it and I'll write it down. Go ahead. If I go GH, I go what? GHDC, GHDC. Another one? Yep. HDBF. HDBF is that one. Another one? EACG is this one over here. EACG. And what else do we have? EF I agree with. And then it's EF, EFBA is this other one. Oops. EFBA. EFBA. And you'll notice I traced them and I tried to use some different colors because it's hard for me to quite keep track and make sure that we have all of them as we go. But those are all the faces. So those top, bottom, left, right, and front and back. And so next I need all of the edges. And so I'm going to have you tell me, like they're all segments, right? So you're going to just say segment this, segment that. And so I'm going to write edges. And I'm going to have you tell me like about 4, and then I'll pause and I'll write those 4 down. And I'm hoping you go in some kind of order that's easy for me to follow. And then 4 more, and then 4 more. So start with the word segment every time. Keep going. Okay, so let me write those. So segment GC, segment DH, segment BF, and segment EA. And I may or may not say them in the same order as you. So now tell me about 4 more. Okay, let me pause there. So segment AC, and I might not say them in the same order. Segment AC, segment BD, segment CD, and segment AB. I think I said them all. And then one more set of them. Okay, segment EG, segment EF, segment FH, and segment GH. Okay, And so you'll notice I kind of traced the box as that person was telling me those, and that helped me keep track of, which ones I still had to write. But please don't write in your book as you do that. So that's just something to keep in mind. Then the next thing we want is all the vertices. And so what are all, just a minute, let me grab another color here. What are all of the vertices on this box? And let me write the word vertices. In any order, I'll circle them as you tell me. Go ahead. Say it again. Okay, got it. Sorry, I have the headphones on, so I. Okay, and the vertices are just each of those points. And so I'll just get rid of all this. So they're E, F, B, A, H, G, C, D. And just those capital letters to stand for all of those points. So make sure you have them. There should be 8 of them. So do you agree? This isn't hard, but it's a lot of writing, correct? And so, just know that there's a few homework problems that are kind of like that where you're going to have to kind of do that work as you go. So the next one, we're not going to write all of that. We're going to say all of it though. So the first thing we have to do is name the polyhedron. What would you call this one? If it has 6 sides, what's that called? Starts with an H, E, X, hexagon. So, and is it a prism or a pyramid? Okay, so yes, it's a polyhedron and it's a hexagonal prism. Now, instead of writing, we're just going to name the bases, faces, and edges. So you are going to tell me the bases, and you're going to say the word hexagon, and then give me the order, and I'm going to trace it, and then I'm just going to erase it after that. Go ahead. What are the 2 bases? Okay, hexagon KLMNOP and hexagon EFGHIJ. And those are also faces. So that's the first 2 faces. And then you're going to tell me all the rest of the faces. And so I want all the rest of the faces. And you can say the word rectangles 1 time and then kind of go. So the faces are going to be these 2 bases, and then we will be listing those right now. So are you ready? Shh. KLFE, LMGF, MNHG, ONHI, POIJ, KPJE. Wow. And we still need to name the edges and the vertices, so we will do that next time.